We're back at the mill, so we're out in the garage, and I actually put my face converter outside so we don't have to hear it. All right, so we're going to mill the lugs first, the top of this. I got it in a 5C collet block, so I can do both operations in this. I can cut both sides on the lugs, and I can turn it around, and I can get the 6 sides on the collet block. So we're going to locate this in the vise standing up, and then later we're going to lay it on its side. So there's a couple of different ways you can do this. If you wanted to be extremely accurate, when we set this up in the vise, we put a dial indicator in here and indicate this circle. We indicate this diameter, and we'll know that our quill is directly on center. So this isn't the most precision component I've ever made. It is just a spanner wrench, but we want it to be close. So what I did was I took this over to the surface block, and I put a dial indicator in it. I flipped it at 180, and I ran the dial indicator both times following the low spot. And the 2 sides that I marked, that none of them are really off that bad. It's only off a 0.5 thousandth. So I'm going to go with using a center finder off these sides to actually locate my center. And I think that'll be close enough, especially for this. I'm going to use a Starrett 123 block to line this up for square. Okay? Okay, let's bring you in. So first thing we want to do, bring you in, get a little closer. All right, so the first thing we want to do is we want to tighten up the collet block. Got my little wrench. Try and stay out of the way of the camera. Before I started filming this, I did stick a straight edge in here, or a parallel, and I made sure this vise was indicated, and it was. And what I use for an indicator is this right here. And believe it or not, this is a tool bit that A-Bomb would be proud of. This is actually a tool bit. Back when I worked for Cleveland Twist Drill, we made a lot of parallels out of the scrap tool bits. And this is one of a pair. And I stick it right inside here, and I indicate against that side. Nice and thick, it's not going to move. This was made 35 years ago. Alright. I'm going to stand it up with that mock facing out, because those are the 2 sides. I'm just going to bring this up till it touches. And I'm going to take my 123 block, and I'm going to pull them together next to each other and then snug the vise. It's kind of a pain, but let's do it this way. Now, what I'll do is I'll feel both sides of this to see if it rocks. See how that's rocking? So it is not, it's not straight. So it's not tight. think I got it. No, a little bit more. Get my brass hammer. And that's pretty straight. I'm going to double check it. Oh, maybe not. Thought I had my square over there. Oh, yes I do. Double check that. I'm just going to look at the light off the gray of this background. And I can see how close it is. That's dead straight. Make sure that's nice and tight. All right, so I'm going to come in here. I'm going to touch both sides of this block, and that's going to, I'm going to use my half function on my DRO, and that's going to give me my center point. Okay, so. All right, I'm going to turn this on. Come up and touch that. As soon as it kicks over. over to be dead center. So I'll pick this up. I'll pick this up, and I'm going to come over to where center is on the digital readout. And I'm reading that right there to be 0. And I look right down the center, and that's 0. And a lot of these digital readouts are different how they do the half function. But right now my digital readout, if you can see it, I don't know if you can see that, the y-axis is 0. Now, and I'm right in the center. I can see that's pretty close. So on our diagram, our lug over here is 185 thousandths. So the slot's 187. Okay. I'm going to use a 3/8 carbide insert. Half the radius of a, or I said the radius of a carbide insert, or a 3/8 insert is 187. So I have to move over the radius of the cutter plus the 185. I'm probably going to go a little bit more. So if I look at my digital readout, what I'm going to do is I'm going to go 187 on both sides. So I'm going to go positive 187 and negative 187. Right now I'm 0. And that will, sorry, not going to go 187. I'm going to go half that, okay? Half the 187. So what's our dimension going to be? Sorry, for a minute there, we would have been real big. We wouldn't have been small. So 185 plus, well, let's divide that by 2, equals plus 0.187. So I got to come over 279 thousandths on each side, 279.5. And that's actually going to make it a little bit bigger than what I need, and then I'll measure it and make sure to bring it right down to size. Okay. All right, so let's get a do a tool change, and I'll be right back. Okay, so we got the tool changed over. We got a 3/8 carbide end mill in there, and we're still lined up the center of the quill, center of the end mill, with the center of the work. So I've got to move this over the radius of that end mill. The end mill is 375, so I'm going to move that over 187. That will put the edge of this cutter right on the line. Then I have to move over half the width of this lug, which is 185. Half is 092. So the 187, the 187.5, the 092.5 is going to make 280. So if I move it 280 one way, positive, and 280 negative, I'm going to get that 185. Okay. Plus I also have to come down depth, and the depth is 190. Okay. All right, so the first thing we're going to do is we're going to make that move, and we're going to check it. So I'll bring you over here to the digital readout. I'm going to move that 280 thousandths. And I'm going to lock it. About a half a thousandth over. It's half a thousandths big, that's not a big deal. We will check it once we mill this. I'm going to come down with this and just take a peek at it. And I took a look at my cutter in line with my workpiece, and it looks pretty good. Looks pretty good. Alright, so now what we got to do is come down and touch, and then come down. Now I'm not going to take the whole 190. I think I'm going to split that in half and take about 100 on the first one and 90 on the second one. We'll see how it goes. But I'm going to come out. Alright, so we want to be running this up around 1600 RPM. High. Everything's tight. I'm going to lock this, lock the quill. And I'm going to come up until I just touch. I think I'm actually going to put some magic marker on that. An optical illusion. It looks like it's going the wrong way. Well, I'm going to back that down to 50. Fits perfect. All right, so I measured this, and this right here measures 187 right on the dot. Let's see what we got now. We got about 186. 186.5. All right, I'm going to take it out. I'm going to deburr it. We'll flip it over and we'll do the hex. All right, so we flipped it over. We're going to locate it in the vise over here. I'm just going to tighten it up first. And what I'm using for a stop is an old Brown & Shop magnetic base indicator holder. I never liked these things. They were never very strong, but they work great for a chuck stop. Okay, so I'm going to put it in here, come up and touch the stop, lock it down. Then what we're going to need to come in over here is find the edge. We can use that same that same end mill. I could actually just come up and touch it with the end mill. It'd probably work fine. It would be faster to mill across the face this way, but that's going to leave us a corner, and I want a radius in there. So if you look at the drawing, you can see the radius in there. A little nicer finish than a corner. Yeah, we could put a corner and then we could hit it with a chamfer tool. It'd be okay, but I want to see how this is going to come out. All right, so I think that's what I'm going to do. I'm just going to come up over here. I'm going to touch with my cutter, and I'm going to go in the appropriate amount. So I already figured it out, and all we had to do was subtract the OD of what we have here and subtract the 750, give us ourselves a little bit of clearance, and we're going to come up with about 54 thousandths we're going to cut off of that. I'm also going to give myself a X axis so they all kind of line up at the same thing, and I'm just going to kind of eyeball that. All right, that looks pretty good. Okay, and again, I'm going to try and stay out of your way. Turn this on. I'm going to let the cutter grab it. Just won't stay in there. So we'll measure our paper, probably about 3, 2.5. I want to go in about 54 plus 2.5, 56, go in 57. table's locked. This is flying too. Radius, so I zeroed my X, so I'm going to go back to the same spot in every one. Picture that. Look at this. Come on, Okay, we're back for the last one. Alright, so it came out quite nice, and I think it looks good with that little radius rather than the square edge. And to make sure it fits on, just about perfect. Okay, so what we got to do is we got to come over to the lathe and we got to put a little chamfer on this side just to make it look clean, and that's all done. Okay, I'll see you over in the lathe in a few. Alright, one last operation. Just want to put a little chamfer on there. Alright, let's see. We look good. Try and stay out of the camera's way. I like it to just break into the flat. And that looks pretty good. Okay, I'll see you over on the bench in a couple of minutes. Okay, that part of the project is finished. So it came out really nice. A nice 45 on there. Actually 30. Came out really nice. The only thing we deviated from the print was the hole inside. And that fits on there with just a little tiny bit of movement. But it came out really nice. It's going to work good, and it fits the wrench fine. and it matches the print. Hey, if you like the content, please subscribe, hit the like button. Thanks for watching, and we'll see you on the next part of this. Okay.